Hello and welcome to another Algebra 1 video. Today we'll be covering both lessons 1.2 and 1.3 in the Big Ideas Algebra 1 textbook. We'll go ahead and begin with lesson 1.2, which is solving multi-step equations. So our objective for today is to first learn how to solve two-step equations. In the case of two-step equations, similar to the one that is shown here at the top of the slide, we're going to be using inverse operations to isolate the variable, similar to how we did in solving simple equations. However, in this case, we're going to be undoing addition or subtraction before we undo the multiplication or division. So in the case of the equation 3x plus 4 equals to 13, first undo the addition of 4 by subtracting 4 from both sides. 4 will cancel out, and 13 minus 4 equals to 9. You can bring down your remaining terms, which is 3x equals to 9. And now you can undo the multiplication of 3 by dividing both sides by 3. Your 3 cancels out, and you're left with x equals to 3, and that's your solution. If you wanted to be careful and check your answer, you can go ahead and plug in this x value of 3 into your original equation for the x value. So 3 times 3 would equal to 9 plus 4 equals to 13. Once you make sure that both sides equal to one another, you can see that your solutions check out and that you have done all the work correctly. Let's go ahead and solve 5x plus 11 equals to 31. Very similar to the previous problem. You're first going to undo the addition of 11 by subtracting 11 from both sides. 11 will cancel out, and 31 minus 11 equals to 20. 5x equals to 20 is your simplified equation. And now you can go ahead and undo your multiplication of 5 by dividing both sides by 5. Your 5 cancels out, and you're left that x equals to 4. You can go ahead and pause the video to try these if you feel confident. If you don't, no worries. We'll go ahead and go over them right now. So for letter A, we have negative 3z plus 1 equals to 7. You're first going to undo your addition by subtracting 1 from both sides. 1 cancels out, and you're left with negative 3z equals to 7 minus 1, or 6. Undo your multiplication by dividing both sides by negative 3. Negative 3 cancels out, and you're left with c equals to negative 2. For letter B, we're going to go ahead and undo the subtraction of 9 by adding 9 to both sides. Negative 25 plus 9 equals to negative 16, and you're going to set that to your 1/2 x. Now recall from our solving simple equations video that to undo the multiplication of a fraction, you have to multiply by the reciprocal. In the case of 1/2, your reciprocal would be 2. 2 and 1/2 cancel out. You're left with x equals to negative 16 times 2. And if you simplify that, you get x equals to negative 32. Now we're going to look at another situation where you have to combine like terms to solve an equation. Now, when you're combining like terms, you're still solving a two-step equation. However, there are a few extra steps. You have to identify what you can simplify through combining like terms. In this case, always look for the variable, such as the x that is shown right here. The variable will show you whether or not the values are like terms. So in this case, we can see here that both 8x and negative 6x both have an x variable. However, the minus 25 does not have a variable, and so does the negative 35. So that gives us the indication that you can actually combine 8x minus 6x to just simplify into 2x minus 25, and then set that to negative 35. And now you can see that it looks like a standard two-step equation. You're just going to undo your subtraction by adding 25 to both sides. 25 cancels, and then negative 35 plus 25 equals to negative 10. Bring down your 2x, and now you can divide both sides by 2. You get that your x value equals to negative 5. Let's go ahead and look at combining like terms in a different situation. In this case, setting up an equation to find the x value in angle measures. So we have a triangle right here. We're given 3 expressions for each of its angles: 2x plus 7 degrees, 74 degrees, and x degrees. And we're given that the sum of all these angle measures will equal to 180 degrees. So let's first set the equation to the sum 180 degrees. As shown in the figure, we know that the 3 expressions, 2x plus 7, 74, and x, all equal to 180. So just set up an equation set to 180 using these expressions. So it would look like this: 2x plus 7 plus 74 plus x equals to 180 degrees. To solve this, we can see that we can actually combine like terms since we have a 2x and an x. Once again, always look at the variable. 2x plus x equals to 3x, and 7 plus 74 both don't have variables, so they are like terms, and 7 plus 74 would equal to 81. So you have 3x plus 81 equals to 180. Standard two-step equation, undo your addition. So subtract both sides by 81. 81 cancels, and you get that 3x equals to 99. Now you can undo the multiplication by dividing both sides by 3, and you get that x equals to 33. Let's look at the second problem right here. Very similar to the previous one, except different sum of angle measures and different expressions. So we have 2x, x, another 2x, and another x for angle measure expressions, and those are all set to 360 degrees. So set the equation to 360, and we know that those 4 expressions stated above will all equal to the angle measure 360. So you can just set them in an equation like this. So 2x plus 2x plus x equals to 360 degrees. We can combine like terms, always look at the variable. In this case, we see that all the terms have an x variable, so you can just all combine all those terms into one value. So 2x plus 2x is 4x, plus x would be 5x, plus another x would be 6x. So we're given 6x equals to 360. Now you just have a simple equation. You can just divide both sides by 6. 6 cancels out, and your x value, it equals to 60. Okay, for another multi-step equation situation, we're going to be using the distributive property to solve for x. So here's a basic outline of the steps that we're going to take, but you'll better understand it once we look at a problem. So number 1, you're going to have to eliminate the parentheses using distributive property. 2, you're going to collect or combine the like terms on the same side of the equation. 3, undo addition or subtraction. And 4, undo multiplication or division. You can see that the last 2 steps are the exact same as solving 2-step equations. So the first 2 are just additional steps to break it down into a standard 2-step equation. Okay, let's go ahead and look at an example. We have 5 times a minus 2 plus 3a equals to 6. Let's go ahead and first carry out the first step, which is to eliminate the parentheses through distributive property. We can see here that we have the expression a minus 2 in parentheses. Eliminate this by distributing the 5, which is the value outside of the parentheses, to a minus 2. So if you distribute that, 5 times a would be 5a, and 5 times negative 2 would be negative 10. So you'll be left with 5a minus 10 plus 3a equals to 6. Now you've finished eliminating the parentheses. You can go ahead and move on to step 2, which is combining like terms. So once again, always look at the variable and see which terms have the same variable and which ones lack the variable. So we can see here that 5a plus 3a both have the a variable. So you can assume those are like terms. Combine those, and that would be 8a minus 10 equals 6. And now you have your standard two-step equation. You can move on to step 3, which is undo addition or subtraction. In this case, subtraction. Add 10 to both sides and 10 cancels out. You're left with 8a equals 216. And now you can undo your multiplication by dividing both sides by 8. 8 cancels out, and you're left with a equals to 2. Okay, let's go ahead and look at another equation. We're given 24 minus 2 times 2 plus 1 equals to negative 6. We're going to first eliminate the parentheses through distributive property. In this case, distributing negative 2 to the expression 2m plus 1. I just want to note that you should always look for the sign in front of whatever you're distributing. Make sure to not only look at the 2, but also look at the sign before it, whether it's an addition or negative sign, because that can definitely vastly affect your answer. So we can see here that we have a subtraction sign before it. So we're going to subtract negative 2 to 2m plus 1. Once we do that, we get 24 minus negative 2 times 2m would be negative 4m minus 2 equals to negative 6. Now identify your like terms. We can see here that we have a 24 and a minus 2, and we also have a negative 4m. 24 and minus 2 don't have a variable, so we can assume those are like terms. We can combine those into 22 minus 4m equals to negative 6. And now you're going to undo your subtraction or addition. In this case, we'll subtract 22 from both sides since this is a positive 22. Once you subtract 22 from both sides, 22 cancels, and negative 6 minus 22 will equal to negative 28. The subtraction sign before 4m was never canceled since we subtracted 22, so it remains there. Now you can undo your multiplication by dividing both sides by negative 4. Negative 4 cancels, and negative 28 divided by negative 4 will equal to 7. So your m value will equal to 7. Go ahead and try these problems on your own. You can go ahead and pause the video to try them, or if you're struggling, you can go ahead and follow along with me as I work these out right now. So for letter A, we're given 5 times 4x minus 1 plus 5x equals to 20. First, eliminate your parentheses by distributing 5 to the expression inside the parentheses, which is 4x minus 1. That simplifies to 20x minus 5 plus 5x equals to 20. Now you can go ahead and combine like terms. Always look for terms with the same variable. In this case, 20x plus 5x, which would be 25x minus 5 equals to 20. Undo subtraction or addition. In this case, subtraction by adding 5 to both sides. That give you 25x equals to 25. Divide both sides by 25. 25 cancels, and you're given that x equals to 1. In the case of letter B, we have 6 times 3a minus 2 plus 5a equals to 57. Go ahead and distribute 6 to the expression inside the parentheses. That would give you 6 times 3a, 18a minus 12 plus 5a equals to 57. Combine like terms, in this case 18a plus 5a, that would give you 23a minus 12 equals to 57. Now undo your subtraction by adding 12 to both sides. That would give you 23a 23a equals to 69. You could divide both sides by 23 now. 23 cancels, and you're given that a equals to 3. Let's go ahead and look at an application problem. So we're given this table with the days of the week and the number of miles we ran on each day. We need to use the table to find the number of miles X on Friday we need to run on Friday so that the mean number of miles run per day is 1.5. Recall that mean will equal to all the values that you're given divided by the number of values that you're given. So in this case, 2 plus 0 plus 1.5 plus 0 plus x. Those are a total of 5 values, so you would divide them by 5. And our goal mean is 1.5, so we'll go ahead and set our equation to 1.5. First, of course, we got to combine like terms. Always look for the variable or whether the term lacks the variable. In this case, you can actually combine 2 and 1.5. That would give you 3.5 plus x divided by 5 equals to 1.5. Now this is a two-step equation. Go ahead and get rid of this divided by 5 by multiplying both sides by 5. 5 cancels out, and you're left with 3.5 plus x equals to 1.5 times 5. That would give you 3.5 plus x equals to 7.5. And now you can subtract 3.5 from both sides to isolate your x. That gives you x equals to 4. So the number of miles you need to run on Friday for the mean miles to be 1.5 would be 4. Okay, now we'll be moving into lesson 1.3, which is solving equations with variables on both sides. So let's go ahead and look at the main objective of this lesson. If there are variables on both sides of the equation, you're going to first eliminate the variable from one side using the addition property of equality. So in the instance of 2x minus 2 equals to negative 3x plus 3, you're going to go ahead and subtract 2x from both sides so that you can put the variable on one side of the equation. Or you can go ahead and add 3x if you would like. Either one works. So if you add 3x to both sides, your 3x cancels, and then you have 2x plus 3x, which would equal to 5x minus 2 equals to positive 3. Now that you have your variable on one side, you're going to do the same thing by putting your constants on the same side. So you would add 2 to both sides, and that would be 5x equals to 5. Divide both sides by 5, and you get x equals to 1. So the objective of solving equations with variables on both sides is to get the same terms combined and on the same side so that you'll be able to solve them. So you can also do it this way by subtracting 2x from both sides, as I said on the previous slide. It will still equal the same value, but you just have different values on different sides this time. So 2x would cancel, and you would be given negative 2 equals to negative 5x plus 3. Now we have to isolate your constants, so subtract 3 from both sides. Oops. And that would give you negative 5x equals to negative 5. And if you divide both sides by negative 5, you would still get that x equals to 1. Okay, let's go ahead and look at an example. We're given 4x plus 7 equals to 9x minus 18. First, we're going to go ahead and isolate the variable on one side. I find that it's easier to subtract the smaller value, so subtract 4x from both sides. 4x cancels here, and 9x minus 4x will equal to 5x. Bring down your remaining terms. So you have 7 equals to 5x minus 18. And now isolate your constants on one side. So you would add 18 to both sides. 18 cancels, and 7 plus 18 equals to 25, which equals to 5x. Now you have a simple equation. Just go ahead and divide both sides by 5, and you're given that x equals to 5. Okay, let's go ahead and look at this equation. We're given 8a plus 1 equals to 3a plus 11. First, I'm going to go ahead and isolate the variable by subtracting 3a from both sides. So 3a cancels, and we're given 5a plus 1 equals to 11. Now you can go ahead and isolate your constants by subtracting 1 from both sides. 1 cancels, 5a is isolated, and 11 minus 1 will equal to 10. So you're given 5a equals to 10. And now you can divide both sides by 5, and you're given that your a value equals to 2. Okay, let's look at the next example. We're given 7y plus 5 equals to 2y plus 10. First, isolate your variable. I'll go ahead and subtract 2y from both sides. 2y cancels, and you're given that 5y plus 5 equals 10. Now you can isolate your constants by subtracting 5 from both sides. Now you have 5y equals to 5. Divide both sides by 5, and that gives you that y equals to 1. Okay, now we're going to look at a similar process that we did in lesson 1.2, which is collecting like terms with equations with variables on both sides. So you're going to go ahead and eliminate the variable from one side using the addition property of equality, as we've done on the previous slides, except now you have an additional step by collecting like terms on the same side first. So you have 6m plus 5 minus 2m equals to 10 minus 3m plus 16. You can see here that you have unnecessary terms that can actually be simplified. So 6m minus 2m will equal to 4m plus 5. And on the other side, you have 10 minus 3m plus 16. 10 plus 16 can be combined into one term. So now your simplified expression will look like this. 4m plus 5 equals to 10 plus 16, which is 26 minus 3m. Now you have the standard form of the equations that we've been solving, and it will be easier to work out now. So you can go ahead and isolate your variables by adding 3m to both sides. That will give you 7m plus 5 equals to 26. Subtract both sides by 5 to isolate your constants, and now you have 7m equals to 21. Divide both sides by 7, and you get that m equals to 3. Moving on, we have one with the distributive property. We'll go ahead and work this out. So we have 5 times p plus 6 equals to 8p. First, distribute 5 to the expression inside the parentheses, since we want to eliminate the parentheses first. That would give you 5p plus 30 equals 8p. And now you can see that you could isolate your variable by subtracting 5p from both sides. And you have 30 equals to 3p. Divide both sides by 3. And p equals to 10. Similar one to the last one, except now you actually have to do distributive property on both sides. So first, distribute 3 to g minus 7. That would give you 3g minus 21. And do the same to 2 times 10 plus g. That would give you 20 plus 2g. Now you can go ahead and isolate your variables. I'll go ahead and subtract 2g from both sides, but you can also subtract 3g from both sides if you decide to. But once again, to make the process simpler, try and target subtracting the smaller values so that you don't have to work with as many negative numbers. So 2g cancels, 3g minus 2g equals to g minus 21 equals to 20. You can go ahead and add 21 to both sides. 21 cancels, and you're left with g equals to 41. Okay, now we have 3x minus 3 equals to 5x minus 6. I'll go ahead and isolate the variable by subtracting 3x. You can also subtract 5x if you decide to, but once again, I'm trying to eliminate the negative numbers to work with. So once we subtract 3x from both sides, 3x cancels, and then 5x minus 3x would equal to 2x minus 6, and then bring down your remaining negative 3. Now you can add 6 to both sides. That would give you 3 equals to 2x. And unlike our previous problems, this will actually give us a fraction answer. So x will equal to 3/2. If you ever get a fraction answer, don't worry. It doesn't automatically mean that you've done something wrong. But if you are trying to be cautious, you can just go ahead and plug it in back into your original equation, and both sides should equal the same value. Okay, let's go ahead and look at this problem. Previously in lesson 1.2, we also did a problem that associated shapes with the concept we were learning. This is kind of the same idea, except we'll be doing these certain equations where you have variables on both sides. So we have the value of the perimeter is equal to the value of the area. Find the value of x. So we know that the perimeter equals to the area. Perimeter refers to the sum of all the sides. So x plus 4 plus 4. And area just refers to the length times the width. So 4 times x. So you can go ahead and set that up as your equation. The equation on the left side is actually just a simplification of 4 plus x. We just combine like terms to get 8 plus 2x. And then your area, once again, would be 4x. Now you can see that this is a standard equation with variables on both sides. And now you can just subtract 2x from both sides to isolate your variable. That gives you 8 equals to 2x. Divide both sides by 2, and you get that x equals to 4. Okay, let's go ahead and look at this word problem. We're given that one movie club charges a $100 membership fee and $10 for each movie. Another club charges no membership fee, but movies cost $15 each. Write and solve an equation to find the number of movies you need to buy for the cost of each movie club to be the same. Now, the key to writing this equation is to look for keywords, in this case, be the same. Be the same indicates that these equations should be equal to one another. So we'll go ahead and set these equations to one another to create an equation with variables on both sides. So one movie club charges a $100 membership fee. So this would equal to 100 plus $10 for each movie. Go ahead and assign a variable to represent each movie. I'll go ahead and put M, but you could choose whatever variable you'd like. So one movie club would be represented by this equation right here, which is 100 plus 10M, 100 being the membership fee and 10M being the $10 fee for each movie. And then the other club will charge no membership fee, so you don't have to put any value for the membership fee, but we know that each movie costs $15 each, so we would be 15M. Once again, we're trying to find the cost of each movie for the club to be the same. So set these equations to one another. And this is the standard form for an equation with variables on both sides. Now just isolate the variable by subtracting 10M from both sides. 10 cancels, and you're given that 100 equals to 5M. Now you could go ahead and divide both sides by 5, and you're given that M equals to 20. Now, if you were to plug in your m value back into this original equation of 100 plus 10m equals to 15m, you would see that those values would equal to one another, and that would show you that you did the work correctly. Thank you so much for watching today's video. Once again, if you would like to request any certain concepts, I have a lesson request Google form in the description box that I check periodically. Also, anything from pre-algebra to algebra 2 can be covered, so keep that in mind when you're filling out the form. For additional practice on these lessons, go ahead and navigate to the Big Ideas math textbook. If you don't know how to do that, go ahead and check out my first video on 1.1 where I show you how to navigate their website. And you can go ahead and try these problems out. I'll leave all the solutions in the description box with work included. If you have any tutoring inquiries, I do offer one-on-one tutoring services. And if you are interested, please email or Google chat me at the following email, which would also be included in the description box. Once again, thank you so much for watching today's video, and I'll see you next time.